Hey, so this is just my progress on learning OpenGL graphics programming. I'm just going to start with the VBO and the VAO. So with the vertex buffer object, we have first we have to create it on the GPU, and it's not actually filled. Allocated or filled with anything yet. So this is what the line here does. This is actually allocating and filling it with the vertice information that we have, and we also have like the size of our vertice array that I specified here. These are just the coordinates, the XYZ coordinates. I have just one triangle and a second triangle to create a square. And basically, once we have the VBO set up, then we need a vertex array object, and the vertex array object is basically how we're going to be reading that data. So this vertex attribute pointer, it specifies that we're starting at slot 0, and it's saying that we're reading 3 vertices or 3 floats. And this specifies the actual stride of what we're reading. So we're reading sets of 3. So it's size of float times 3. That's just the XYZ, and then we're going to move to the next set, which is another XYZ. And then this just lets us know where we're starting in the memory location. Because if we were to say the void pointer is just a generic memory location, it's not like an int or a float. It's just it has no type basically. So this is the offset. So you could potentially start the offset at 12 bytes, and that would be basically the second set, because the three floats is equal to 12 because a float is 4 bytes. And when we're kind of stepping through the sets, this offset is basically going to be saying, okay, when we start at the beginning and then we're doing the next set, we're going to be starting at void pointer 12, as in 12 bytes. So that's important because the slot 0 that I mentioned is mentioned in the vertex shader that I have here, and that's going to be filling a position with each set. So it's going to and that's determined by the vertex attribute pointer, which is kind of dictating how that's going to be read. So each time you draw, it's going to do the first set, and then it's going to stride to the next a set of 3 vertices, and then it's going to draw that. So the vertex shader is responsible for determining where on the screen the location of the vertices, and then the fragment shader is responsible for actually coloring the pixels that are in the border of that vertice. Mine's a square, but it could be it's a triangle usually, obviously, as I mentioned, but I'm drawing 2 triangles to make a square. So there's also a middle process which is called rasterization. So it starts with the vertex shader to determine where the position is, and then the rasterization, it determines what pixels are actually in that vicinity or location or border. And then the fragment shader is actually what colors all of those that are in that border. And this is just the fragment color. That's going to be an orange. And lastly, we get to the actual loop. So each time we're going to be drawing the we're going to draw it each time, and it's going to be calling the vertex shader to draw it each iteration. And how it works is you have a front buffer and a back buffer. So the back buffer is what is going to be drawn to, and that's going to be the actual triangle and where the shaders were calculated to be. And then the front buffer is just the display, so that's going to be what is actually seen. And so that's happening in a loop. You have the frame that's actually seen, which is the front buffer, and then you have the GPU rendering the back buffer with the information, so it's constantly flipping through that. And it'll depend on your frame speed. Like if it's 60 hertz, it's going to be like 60 frames per second. This loop actually runs at a different frame time, so there might need to be some synchronization happening when I actually get to like actual animating, because it's just looping the same image over and over, so you don't really see anything different. And I'll just show you what it looks like. So yeah, this is the actual square that I've rendered with OpenGL. Yeah, so it's been pretty fun. I'm lucky, or I'm excited to learn more. But yeah, that's about it.